every engineering problem starts with bounding. You have to bound what it is that you're looking for, and then you have to bound what your solution is going to be able to do. This isn't a failure of ambition. It's actually part of your ambition is to define it in such a way that you can meet the greatest needs in the most effective manner. It is part of the engineering job to do this. So the same logic applies more broadly to many things, is that you have to create boundaries to be able to create solutions that work. And it is part of the life in technology to work with it with boundaries and define those boundaries. But beyond that point, it gets complicated, right? Because the boundaries that worked yesterday are not necessarily the boundaries that are great today. Even the best engineer has finite time and attention. You can't parallel process your way out of being human. Corporations developed originally, right, after in the Renaissance, and then over time, to solve this problem, to scale up artisanal work into a way of delivering solutions at far greater scale. And then, the Renaissance and other things, they attached capital to this. So you developed capitalism. You go back and you look at what Adam Smith said. He basically said that you can be vastly more effective by breaking work up into a series of processes that people do. Just that process is much more effective, and you can scale that. You can't scale craft work. So you divide the work, you run it in parallel, you deliver at scale. In small firms and in startups, that's maybe not quite so true, but once you get past that initial phase, then you have to start chunking the work, and you have to start creating methods that allow you to scale, allow you to bring more people in, to grow something, to basically break it up so that you don't have to have humans with superhuman skill sets, that they can have a skill in sales, have a skill in purchasing, have a skill in engineering, and then you can make great use of all of those people to build a great corporation. But with time, those chunks harden. You have always the information problem of that you need a hierarchical structure, and then you will need management. And then management is going to have a tendency to create their own fiefdoms. And so you get stovepipes. What we call this, when it gets really bad, we call them stovepipes. And the roles are defined, the processes are documented, and then ISO arrives and things get ossified. If you look back over time, through my career, essentially what happened was the 1950s corporation and the Matrix Corporation then had the ISO process concepts that kind of came out of Japan, and a lot of what they were doing, they were bolted on together. And then you have that, plus you have staffing reality, you have the whole networking issue of communication and management hierarchies. It basically becomes a very rigid structure. And Conway's law of organizations say that organizations basically have a structure which is defined by their information structure, and that's how most of our corporations are organized, right? Engineers develop the data package, they hand it off to manufacturing. Manufacturing has process engineering, and they have the purchasing department, et cetera, et cetera. So you can see it in a very real way wherever you are. And none of this is malicious, and it's not even bad. It's really was necessary for many, many years, but it is also a system that can be limiting. And as the tools for communication, information sharing gain ground, it probably is a limitation that we need to relook at and move beyond. So I'm going to tell 3 stories about my own career. kind of to where I was very much in a kind of a role where I was spanning the organization and we had success, and a role where we had much more of a structured stovepipe type organization, and where still success, but the gains were more limited. Back in the late 90s, I worked with the Navy on the power electronic building block, and that program was looking at all the packaging and the devices, etc., for power electronics to create these building blocks that could be scaled up by just kind of adding them together to create larger and larger power electronic systems to convert electrical power. I was helping in on the manufacturing side and the packaging side, and one of the jobs I had was interfacing with a variety of companies. One of those companies was a company called Satcon, which I worked with later to develop that concept a little bit more. They took that work and got a contract called, or a grant program, cost share grant program with Department of Energy called AIPM, Advanced Integrated Power Module. It was an outgrowth of PEB. And over multiple years, I was a program manager for that. And I was also essentially the lead engineer. And so I interfaced with actually the big three auto companies, along with the Department of Energy and the Navy, to develop this module. And, that was all the way from the cooling structure to the housing, and included how do you package devices, how do you attach devices, how do you create the power structure, et cetera, et cetera. And, a lot of that was fairly straightforward. We used a lot of concepts that were very much in vogue at the time and still very much common today, of making it, essentially building it in layers, building it in ways that makes it very easy to assemble, breaking the design up into those elements that were most effective together, and then bringing it together. One of the key elements that we developed during that time was that because the power electronic, the chip that does the power conversion, you have a minimum of 6 of those chips. And in fact, 12 was actually most of the time is what we had, 12 of those chips, any one of which that failed at any time would scrap the whole module. And because we were building these modules into essentially a kind of a semi-solid state structure, you couldn't rework it. You threw the whole thing away if it failed. And so one of the elements that we came up with through the iterative process was that you needed to make those into these testable mini modules that allowed you to do all the testing and stressing, and then you mounted it permanently into the overall module. And then you had very high yield, and your manufacturing process could be refined very effectively for quick build. That approach has actually become the standard within the automotive power electronics for automotive market. If you look inside a Tesla motor drive, they use essentially the approach that we originally developed for AIPM. We developed it 20 some years ago, and we developed it with a relatively small amount of money, and proved it on a prototype production line, etc., demonstrated all of that. And we did that within about 3 years, and that was because I could work across manufacturing, design, electrical simulation, and mechanical design. I could work across the whole thing, and we could iterate very quickly and come to a solution. So for very small, by these days standards, amount of time and effort, we were able to take it from concept to final resolution and build those modules and deliver them. So that solution is still the common solution today. So after that episode, I moved on to a company called DRS, DRS Defense Contractor. I did multiple things for them in the same area of electronic packaging, electronic manufacturing, but directly related to large permanent magnet machines. So, and motors and generators, that was that business's primary thing. But with that, we always had to have electronics to do power conversion of one sort or another. So midway into that effort, we had been doing a number of different proposals for the military. The military was looking for large amounts of electrical power out of their vehicles. And you already had an engine there and the vehicle was moving around. So why can't you generate a lot of electricity out of this instead of always having it that as mechanical power? So a lot of work had gone into trying to do that by putting large alternators on those engines, and that had never worked. And then the other approach was to put a sandwich between the engine and the transmission to do the same thing. And again, the problem there was that most vehicles are pre-designed with a transmission and an engine. Putting an electric machine between the two of them just doesn't work most of the time because so many things have to be changed that it becomes unachievable unless you design the vehicle from the get-go. And even then, it's sometimes a problem because you don't want the vehicle to be longer than a certain length, and you no longer at that minimum length if you put this sandwich in. So I have been working with Allison Transmission, who is the premier producer of industrial vehicle transmissions, and also, by the way, the transmissions that go into almost all the wheeled vehicles in the U.S. Army, U.S. military fleet. And that we've been working on these various solutions and worked together on them and been kind of failing again and again because we couldn't meet the Army's wants, and it just wasn't working. So actually, DRS had shown that you could have this solution where you integrated the generator into the transmission of a Humvee, and had done that a decade before. Allison worked with us because of that work, and eventually I and the team at Allison, talked through what we could do, which was to take the standard transmission that goes in most of these trucks, take the bell housing where there's usually a power takeoff, a mechanical power takeoff, take that out, replace the mechanical with a generator, the biggest possible generator, and then attach the power electronics, which DRS was already making, to that to deliver a solution. The Army didn't want that solution because they were resistant to continuing to have to buy Allison transmissions. So they weren't willing to really kind of buy into that. So we went off and developed that under IRAD funding. And we developed that again in about a period of 3 years for a relatively small amount of IRAD money. We built that. We were able to build a series of those machines. We put them into MRAPs and other vehicles with the support of the vehicle OEMs, and demonstrated it to the Army at their network demos that they were holding every year. And there was great success. The general officers were very happy with it and kept on asking why couldn't we deliver more of them so they could take them out to the field. It was a very successful program. Today, that program is actually gaining traction because some of the rules and some of the philosophy that had resisted what we were doing have changed, and they're pragmatically taking up the technology which is available. But it took 10 years for that to happen. It's a painfully long time. So the third story is my time at Wolfspeed. I moved to Wolfspeed intentionally because their products were going out to customers already, and I could be engaged working with them on the industrial side, the civilian side, and getting products out the door. I helped design and redesign several modules, and also extend several families of modules by putting new generation devices in them, updating materials, doing a bunch of that kind of work, and had about 15 different products, probably more than that, go out the door and be available for sale even today. And, so that was good. The frustrating part of that was because Satcon, Wolfspeed, because it's that type of organization, was very much a stovepipe type organization. Marketing was marketing, sales was sales, test engineering, module design engineering, device fabrication, manufacturing. It was all highly structured, and even pieces that you would think might even be in the same organization were in different organizations. There were reasons for that. It had grown up over time. There was, good rationale originally, but it was very stovepiped. And what I found was that when I was bringing these new products out, because there were never enough people in the various organizations who were able to say, I am the expert for this class of modules or that class of modules, often what I would end up doing was essentially going and working with them and doing what nominally was their job, and I would jawbone them into getting the job done and get it done. So it was very onerous to go through all of these process steps to get from concept design all the way to product release, which is a lot of different steps. If any of you have ever gone through it, you know the number of steps you go through. And none of it was automated. Infrastructure was always in development. It was never really there. So you were constantly in the mode of kind of filling in the gaps all the time. And because of the stovepipes, there were a lot of cases where you had to hand information off and then basically go and jawbone it into place rather than have it go there naturally. And that was largely because these stovepipes were in place, but you couldn't do it for them. They had to do it. So it took time, it took effort, it took them having to go get their assets in place, even though they had agreed that they were going to go do it. They still had to then say, okay, go up to their boss, say, okay, I have this work, we've agreed to do it. Can I get priority to go do this work rather than the stuff you've said is number one priority? And so, it was a constant struggle, and it was a struggle because of those stovepipes and having to try and span them without being given remit to span those stovepipes. So the stovepipes were there to protect quality. The problem is it also stopped progress because the channels were always kind of basically a bit blocked up to get the work done. So my view, having been outside of that for now quite a while and working with the new systems and following very closely what's going on in manufacturing kind of worldwide, what is going on in AI and information tech. To me, it is very reasonable to think of AI as vastly more than a search tool, as a tool for information management and for the amplification of the individual, right? So you are no longer in a world where you need to be limited by a system that is in place and always have to operate. You always need a information flow. That process, what is supposed to be that process, is a way for information to flow. But you should be able to use the AI to flow that information through the right channels in a much more effective, efficient way, and not require every step to be curated by a specialist and somebody who picks up that piece of information and does something with it. You can automate that and move it forward. And we need to be doing that. You then need to have people thinking at a much higher systematic level, and thinking about and allowing for the movement of the product through the processes in a much more organic, flowing way, rather than a series of kind of flows. You would fill this pipe up, and then it would overflow into the next pipe, and it fills up, overflows. Instead of that, the flow is much more smooth, and should be able to gather its own momentum, velocity, and move out much more quickly and effectively. So this isn't replacing engineering. It shouldn't replace very many people at all. What it should do is enable the people who are in the system to do their job much more efficiently and effectively, and work as a kind of a networked brain much more effectively. So again, my experience at AIPM and OBPV were, as you know, your span of effect was much broader. You were able to bring solutions to the table and out and put it out much more quickly and effectively than if every one of those steps had to go through that kind of fill up the pipe and let it flow over, and we would not have been at the end point by the time I left those programs. If we had had to do that, we had basically moved the whole thing forward kind of in parallel. And what I'm advocating is that the tools allow us to do that, and we need to get away from the very structured organizational map hierarchy, and allow people to span and remit to move forward more effectively. Now, boundaries are still necessary. You have to bound the problem, you have to bound the solution. You can't just go off willy-nilly and try and solve every problem all the time. That just doesn't work. But that doesn't say that once you've done all that, that you have to then live within the boundaries of stovepiped organizations to bring those solutions to fruition. You basically need to move forward much more rapidly using the tools that are available today and will be even ever more available in the next few years, and apply those in the physical world, not just in the software world. There are huge gains already being made in the software because the tools are eventually working with code groups, and so it naturally flows to software very quickly. But the ability to handle information, the ability to organize information and flow that organization, and to amplify the engineer and the technician and the worker's capability, will aggregate to everybody within the organization, and we need to take advantage of that. Companies that don't are essentially going to get eaten up from below through the innovator's dilemma. The innovator's dilemma being that if you are very good at something and you have a way of delivering that something, it is very hard to see alternate solutions. And the problem is that the people coming up underneath you will see those other solutions, will deliver those other solutions. Sometimes they may look like they're sub-optimized in some way, but they will often be cheaper and easier to implement in a niche. They will eat that niche, and then they will eat other adjacent niches, and suddenly you'll find yourself out of the job, right? And rapidly losing market share. And I see that coming for a lot of companies who don't implement much more open span of control and more dynamic teaming using the tools that are becoming available. So I think if you're an engineer, I think a lot of you will see some of these issues, and I think you can probably identify where the stovepipes are. If you're a manager or executive, you need to look at your organization and look at it and say, are those stovepipes limiting what we can do within any period of time? And if I open that up, or if I give the tools or allow the tools to be used in an effective way by the people who can use them effectively, can I suddenly say, instead of delivering one product a quarter, I can deliver 4 products a quarter, or one product every 2 years, I can deliver 2 products every year. Who knows? I mean, it will depend on the industry, but it does seem very realistic to see the ability to move much more quickly, spreading across the hardware industry very rapidly. So that's my view from the unretired engineer's seat. Hopefully it's provided a bit of value, bit of insight why I think these things. So hit like, hit subscribe. If you have a question or a comment, hit comments. I'll be coming back soon to talk about issues in engineering, engineering projects, technology, and writing science fiction. Cheers.